Alright, so looking at how to integrate an exponential function. This is really easy if you remember that integration is the opposite of differentiating. So knowing that when I differentiate e to the power of x, I get e to the power of x, then conversely, when I integrate e to the power of x, I should get e to the power of x. So that one's really straightforward. What you'll see here in the box is what is given to you on the reference sheet in the HSC. So the integral of e to the power of ax plus b, we end up with 1 over a, which makes sense when you consider what it was we did in the last lesson. If I had to differentiate e to the power of ax plus b, I ended up with an a out the front. So inverse, we're going to end up with 1 over a. So look at your first example, the integral of e to the power of 3x plus 2. Well, in this case, a is 3, so this is equal to 1 over 3, e to the power of 3x plus 2. And then don't forget, this is indefinite, so you have to put in your plus c. Now, this works with really complicated ones as well. So if we have this function 1 minus x plus e to the power of 2x, you just integrate each term just like before. So when we integrate 1, we get x, we integrate x, and we end up with x squared over 2. And then when we integrate e to the 2x, we end up with e to the 2x all over 2. And then we do our plus c. Now you can combine your x squared plus e to the 2x over 2 if you like, or you can leave it like that. Looking at number 3, so we're no longer looking at an indefinite integral now. Now they're asking us to work out the integral of e to the x from 0 to 2. So this is the calculation you would need to do if they wanted to know the area under the curve of e to the power of x from the point where x equals 0 to x equals 2. Okay, we know that when we integrate e to the power of x, we get e to the power of x back, and we want it to go from 0 to 2. Now, unless they tell you to give your answer as a decimal or correct to 2 decimal places or something like that, you will be expected to leave these as e to a power, because that is the exact answer. If you type e and then the power into your calculator, then anything you give me is going to end up being an approximation rather than an exact answer. So I would expect you to be telling me, well, that is e to the power of 2 minus e to the power of 0, but we know that anything to the power of 0 is 1, so this is equal to e squared minus 1. That's pretty much it, guys. So that's what you need in order to do exercise 4.3. Good luck, and I'll see you in class.